I'm using Git for version control in Accord, and Git doesn't normally allow you to commit files larger than 100 megabytes. But the World 1 scene that I was working on previous week exceeded 100 megabytes, so I couldn't commit my changes, which is a big problem. So I reduced the scene size to 3 megabytes. The reason why the scene file was so large was because I was spawning a game object for every single tile in the world, even if that tile was empty. And a game object uses a lot of memory. It has a name, it has static flags, it has a tag, it has layers. The transform component has scale and rotations, which I never use. And the sprite renderer has a lot of properties, which again, I never use. So what I want to do is give these tiles to the GPU directly, without having to use Unity's game object system. And there's actually a very good way to do that. It's called instancing. Instancing is basically when you draw one object multiple times with slightly different properties. GPUs can work way faster with instancing because it doesn't have to constantly switch models, materials, and so on. All you have to do is upload the per instance data for each tile to the GPU, and the GPU will draw that without any subsequent calls. And there's only really two properties for a tile. Its position and its sprite, or its texture offset. So I have a struct in the code called tileData, which holds the per instance data for the tiles. It has a position, which is a vector tree, that means x, y, and z. Now normally the game uses only x and y to represent the tile position because it's a 2D game, but I use the z coordinate for sorting. And I have a vector 2 for the UV. So whenever I update the tile map, I first clear the foreground and background tile data lists. And then when updating the tile UVs, I add those values back to the list. After that, I upload those to the GPU, and then every frame I use the tile map material to draw instance tile meshes. And we also need to specify the count. And that's easy because the count is exactly how many tile data we've uploaded, which is tilesBuffer.count. So here I draw a solid quad for every position in the tile data buffer. And then I need to supply the UV coordinates so that each tile gets drawn correctly. This part was somewhat trial and error, but eventually I got it to work. But then I encountered some problems when trying to draw the background tiles. For some reason, they wouldn't draw at the places where they meet the foreground tiles. And then I wrote a bunch of debug code trying to understand what was going on, but everything was set up correctly from what I could see. After a bunch of experimenting with no result, I tried looking at the scene from 3D. And then the problem became apparent. I was not clipping the transparent parts of tiles, which were still writing to the depth buffer. So background tiles didn't render because they were behind the foreground tiles, even if they were supposed to be visible. I fixed this with a simple alpha clip, which basically discards the entire pixel and doesn't write to the depth buffer at all. And then everything started working correctly. After I was done with the instance tile mapping, I began working on wall rolling. Wall rolling relies on the fact that the player is touching a wall when he is rolling. But if the surface is convex, like the one you see on the screen right now, the player can be at a position where they are not touching any pixels at all. And when that happens, they stop rolling. So here's how I fixed it. When the player stops touching a wall, I push them 1 pixel towards that wall. After that, I push them opposite to where they are moving, so they are touching a wall again. After that, depending on the player's orientation, I either rotate the speed counterclockwise or clockwise. And then the player is ready to move again. After that, I added some editor tools, because it was getting tiresome to always having to pause the game and change things from the scene view. I added a free cam so I can look at the levels from a wider angle. I improved the editor cursor, it can now place background tiles and remove tiles. I also added the ability to teleport the player to where the editor cursor is, which is the most useful thing ever. Now I can go between levels in seconds, and if I want to go somewhere in a room quickly, I can do that as well. I also added a debug overlay, which shows the speed, the position, and the subpixel value of the player. I also added the room name and the room dimensions, and the cursor position. After that, I made the player die when they're squished between two objects. And finally, I made the player continue where they left off when they exit and re-enter the game. The stuff I've done this week was very technical and there wasn't a lot of visual things to show, so next week I'll work on more visual stuff. I still haven't decorated World 1, so I'll make a lot of images and splatter them across the world, and I might also start working on the tile map and background art for World 2.